I looked at what is the first processor which has come, right? At that time IBM Heron, right? Was there. Now in Quantum Valley, what is the processor being installed? Quantum processor is being installed. QPI-AI. QPI-AI is first Indian made quantum processor. But Indian made quantum processor is only 25 qubit. Right? Indian. Flora. There are so many models, but what is being installed in Quantum Valley?
IBM, sir.
Yeah. After IBM. Kisket is simulator. So this is IBM Heron 2, right? IBM Heron 2 is the IBM model. Heron 2. This is being installed. So this is 156 supercomputing in November. Right now they are trying to increase it. So this is 13 November 2024. Very recent. So that's where we started. And when I was introducing, so we are learning from IBM. The workshops, many of the speakers are coming from IBM and teaching. And we are benefiting from it, right? The videos of these lectures are available. Okay, they are available free, open. Go to YouTube, type MNIT, type Quantum, and type AICTE-ATAL. Okay, AICTE-ATAL. I will show you the videos, right? So all these videos of the last 3 courses are available. Like that, some 100 videos, some 100 different lectures conducted by CDAC, they are all available, right? So what is the gap is our time, right? More important than quantum time is our time. So my whole coming point of coming here is to just motivate you, and that's why I think Madam also wanted to tell. In spite of so many responsibilities, this fellow is doing so much. So please, you also do. That is a challenge, right? June 30th, I submitted 2 PhDs. 2 of my students submitted PhDs on the same day. Right, because that was the last day, so I had to check all those papers, all those documents of 7 chapters each, so 14 chapters of PhD thesis. I checked in 1 month. June 2nd was there, and then so in that month the things were going on. Quantum workshop was going on, certificates released, then convocation of related quota. In spite of all that, we should take out some time. So that's something which we need to do. One professor put his textbook, full textbook, not full textbook, but he put his slides and videos online. One US Chinese man who is now working in India, working in US, he has put 2 textbooks material, full content in slides and in videos online. Just imagine if you are able to do that course with him, not registered, just to follow that course at your free time when you are traveling by bus or something, and then you can complete. So this is the question. So this is 156 supercomputing qubits. This is the processor which is readily available. Second one that is there is Microsoft Majorana. Right? This is topological qubits. Okay, they have long-lived states. So here the power is they are using topological qubits. Right? We will study some of these hardware aspects. It will be easier because some physics background is there. I think you will understand the words. But then yes, so this is maybe we can read a little bit later. Microsoft has come up with this. AICTE has come up with this. Right? AWS, Amazon Web Services has come up with OCLOT. This is they use what is called CAT qubits. Okay, 80 CAT qubits. What is CAT qubits? CAT qubits basically has less quantum errors. Right? So you have to study about quantum errors, how to minimize quantum errors. Right? That part is over. Right? Now measurement. Okay, how is measurement done in quantum? What is the prerequisite? Or quantum hardware, when we talk about, what is the prerequisite? Gates and
quantum process, classical computer interface,
algebra, gates, yes. When will it work?
interconnection,
all these are gates. When will these gates work?
all are done in the quantum process.
What is the requisite for this quantum process?
By using the quantum algorithms. Qubits.
When will it work? What is the other requirement? Now we are, see, whenever I am asking these questions, don't think about the the internal processor, what is happening. You are all talking about that, AICTE. I am talking about that processor will only work.
How it takes.
Kelvin degrees. Good word. This is what I was looking for. Kelvin. What is Kelvin to do with process?
Temperature.
Temperature. Why the temperature is needed?
Because it produces a high heat. That's why
Noise. Noise is not there. Noise will not be there. And then measurement will be more accurate. It will not be still error free. But so now you have to understand what is the requirement for prompt. Now when you have a processor, I cannot run. So one day we are talking in our college in MNIT Jaipur, one professor electrical, I said, sir, we need air conditioning. He said, why you need air conditioning? I said, sir, processors need air conditioning. I don't need air conditioning. Because I should not say, sir, computer science faculty needs air conditioning. Then he will say electrical also. So he said, see, all my machines are connected to processors. Systems are working. There is no air conditioning. They are all working now. I said, yes, sir, they are all working. So why we need now these days process will work without air conditioning. So no need of air conditioning, we will install fans. I had no answer. Later I said, sir, okay, take a UPS you need. He said, why UPS is needed? Sir, some program is happening, there will be power failure. Then he said, see, I am handling the state electrical, I am electrical there. How many times your power failure happens in one columns? Monthly, one time. So what happens if the power failure happens? No need for UPS, you manage. If some big calculations on PhD student is doing, suddenly the power fails, he will have a big problem. Okay, he will take another 2 days. He will run the program again. What is there? So okay, once or twice it will happen in 1 month, no problem. So don't give such reasons. Okay, no, UPS also will not. So like that. So now when I did not have any answer, because now it is working fine. Our normal computers, classical computers, will work at room temperature, no problem. Right? There are no errors. Okay, measurement is almost 99.99% accurate. Understand that there is some failure when you are using big cluster and one system fails, there may be some result fail. That also Hadoop kind of systems are able to manage without error they will be. Right? So these need that temperature. Okay, to run at minus 273 degrees. Okay, that is the basic idea. Then Google below came up with 100 plus qubits, but that's where they are saying that we are reaching the quantum abundance. And I was a little, because these are all not surprising for me, Google, Microsoft, AWS, obvious understood, right? No problem. They will have to do it, right? They have to survive. But I was surprised by this. Jaipur 3.0. Right? This was made by China. Right? So they called it a China's processor, China's quantum processor, China's QPU, and this is 176 qubits, one of the world's largest gate-based chips. So this is the most powerful quantum computer, quantum processor that we can look at. But it was made by it is made by quantum. It's a quantum powerhouse. 4th March 2025. 3 months ago. 2 months ago. It was 176 qubits. You have studied qubits, right? That also I will ask you questions. We try to answer. Then later Japan came up. Japan came into quantum computers, so it was called Riken quantum. This was by Japan, right? So 64 qubit quantum computing, supercomputing test bed for National Initiative Superconducting Technology 2025. This is also very recent. I got this news maybe 2 months ago, maybe sometime in May they introduced. So this was the thing. So let me introduce you to. supercomputer, quantum computer. That was a glimpse. So I was in quantum computing, this company QPI. So it's a small, this floor that may be the size, but this quantum computer was placed there, right? A 25 qubit quantum computer. So it was in room temperature only what we got, but the covering that you could see, the white cover, right? Inside the white cover is this. Inside that white cover, yeah. So that quantum computer, that is the quantum computer that you are able to see there. This one, this is the quantum computer, and inside that the temperature is maintained. So this is the office. So this is the inside part they are showing when it is not on, right? So that is how it works. Otherwise, this is also open like this. And inside a cubicle, which is completely maintained at -20, right? It will be in a white glass chamber. It can be open. You would have seen some videos like this. Go into YouTube and type a quantum computer, you will see many videos like this, and how the things are constructed, right? Later they talk about their companies this thing on AI and other things. So they are integrating AI and quantum, right? So now the question that is coming to me that I want to understand, how much of quantum you have picked up, so that we correlate that. Once we correlate that, then you can, there is a challenge for you, right? Now you're understanding from the top of the stack, you understood how a quantum works, how the gates work, right? How I can write algorithms, how I can write Qiskit programs, then how I can write an application level program which can run on Qiskit and solve some problems. How I can write data, how I can classify a data set, right? I write some machine learning algorithm, right? Quantum machine learning briefly must have been introduced, right? Was it introduced? Quantum machine learning. Penny lane you have heard of? Penny lane you have heard. So penny lane is used for computer vision if you are working on, or any natural language processing problems that you are working on, you can work with them on penny lane. So for quantum machine learning you can. Now how do I learn quantum penny lane? Some introduction must have been given. How the tool is installed and all, you would have seen. Now the question is, we have to start working, right? Maybe with your students, they will start writing the codes and you will have to check, right, whether they are writing. Many times students try to deceive us, right? Please understand. And why am I saying that? Because we are not running the code, they are running the code, and they show the results have come. Because what we are wanting to listen is that only. Then okay, how are the results are come? They have given some table. Then we say okay, please sit with them and ask them to show the running. Right? What happens is people are able to guess what is expected. You will also tell, right? As a problem statement, you will say you run this, you may get this kind of expected output. You will tell them. So what they will do, they will try, and after some time they realize it very difficult. It will take a lot of time. Okay. Because the code is not readily available on ChatGPT also, right? ChatGPT helps them to a certain extent and they can get the code. But that code has to be modified, and they know it will take time, or they don't want to do it, or they have done it, they don't want to tell you. So results have come in 2 papers like that, not in quantum but a machine learning we published, and it was questioned. So then when I tried to understand what went wrong, when the results are good, why the paper was not accepted, is that they are not executed. They guessed and told me the results. I said, okay, write the paper. They wrote the paper. The person who is reviewing the paper knows what exact results will come because he has run those programs. So he rejected. So when I came, I was upset because the result is good, why he has rejected. So then I asked them, show me the execution. Then they are telling, sir, this, that, right? So I realized you are not executed. Now you execute. Now we will send it somewhere. right? So please understand that don't rely on students. Students are very good, they can do better. After they do, they may want to tell you, they may don't want to tell you. So please take the code for them, run the code yourself. Whatever age you may be, please don't feel bad. Sit with them and say, chalo, run just 2 people, right? Run just 2 people, right? And then that can take you. Let me come back to till the power comes. Let us look at few more questions that we can we try to assess, right? Now the temperature is low at that time. What is the reason for temperature being low?
Sir, at that time atom will be stable.
Okay, so what will that result in?
Less errors.
Less errors, right? So that's what we did. So first thing is the temperature is needed to maintain at that temperature so low because the errors must be less. That's the first thing, right? And now second thing they say cryogenics are used, right? When I looked at that system, I asked them one question. You also will ask. If you see that system, what question you will ask? Is the material used? What is the material you will ask? They will tell you. Then we will ask uranium and gold, right? So they say we will ask whether all these things are made in India or not. Okay, so they said that everything is made in India except the cryogenic unit. Okay, cryogenics, physics people should tell. What is cryogenics?
Low temperature. Keeping a body in low temperature.
Right. So maintaining that is the challenge. That is not there. So they imported that and so that Japan thing I showed similar to this AICTE. So they got that. So now that is a challenge for India. They have to manufacture that. Now let us come back to the other question of processor. Now in CPU, right, zeros and ones are running. In QPUs, what is happening? Qubits are running, right? Now, what is the relation between a bit, classical bit, and a quantum qubit? What is the relation?
The quantum bits have superposition and entanglement.
Superposition and entanglement. Yeah.
Stable state.
Two states. Here, multiple states. Now, please try to understand what these multiple states are going to do. How these multiple states are possible. At a time, multiple states. Here, only 2 states.
At a time, only one state.
Only 1 state. Here, it can be multiple states. But finally, when you do measurement, it will be 1 state. Right? So, final again, it will become classical. Can you think of some relation, especially mathematics and computer science people? Huh? 2 power n. Yeah. But what is the thought process which is already available in some of the mathematics and computer science textbooks?
Orthogonal, orthonormal,
Orthonormal.
basic sets.
Any other mathematics?
Inner products.
Direct notation.
Direct notation is mathematics.
Inner products.
No, the concept. Multiple states.
Linear array.
Multiple states finally collapse into classical states.
Superpositions.
Right. Let me give you a hint. Automata theory.
Turing machine.
Turing machine is universal. Turing machine is there, but before Turing machine,
Automata theory.
the thought of quantum, from classical to quantum, is before Turing machine. What are the other machines?
Basic machine.
What is the basic machine? Starting first level.
Zeros.
There are 4 machines in automata. Arey, he knows everything you are thinking. No, I don't know. I taught automata theory, so I know. But all of you have studied automata theory. Maths and computer science would have taught. Physics would not have studied. But mathematics you study in physics also, right? When you are doing your BSc, at that time you would have studied automata theory.
Switching theory and automata.
Switching theory and automata is different. Switching theory and automata is different. Yeah, I think there also automata will come. Formal language and automata theory or
Yes.
Before that, first automata.
Chomsky hierarchy of languages are there,
Yeah.
sir.
First
Type
language.
0, type 1, type 2.
Type 0 machine.
Type 0 is Turing machine.
Type 4. Type 3.
Type 3.
Whose machine?
Context free language or context.
That is 2, 3, 0, 1.
Learn automatic.
What I want you are not telling. Everything else. Okay, let me tell you the answer. Let us not waste time. Finite automata.
Finite
Ah,
automatic.
finite automata.
Finite automata can see 0 or 1. If it sees zeros, it goes to one state. If it sees 1, it goes to
Deterministic.
deterministic. Will go to either state, either 0 or 1. If it sees 0, it goes to one state. If it sees 1, it goes to one state.
Okay.
Non-deterministic finite automata. If it sees 0,
Goes to one.
Non-deterministic means we cannot
We can
decide.
say
non-deterministic means it allows us to see 0 and go to multiple states. You see 1, you go to multiple states. At seeing only one input, you can go to multiple states. On seeing another input, you go to multiple states. Now, using non-deterministic finite automata, we can solve so many problems. Because at a given time, you can create multiple states. And finally, what they say is non-deterministic finite automata is equal to finite automata. Okay, for those who have not studied deterministic finite, computer science and mathematics people have no excuse. Physics people, you please go back and read what is finite automata,
Yes, sir.
what is NFA and DFA. Finally, they say NFA is equal to DFA.
DFA.
Okay, non-deterministic finite automata is equal to deterministic finite automata. Means, finally, I can be at multiple states. That multiple states can be considered as one state.
One state.
And on seeing 1, I can go to multiple states. Those multiple states may be considered as one state. Right? And from those multiple states, I can go to another multiple set of states. But those multiple set of states become one state. So at the end, all these multiple states become one state each. And finally, it reaches the accepting state. And finally, the string is accepted or not
Accepted by the machine.
Right? Please understand. This is the background for which, that's why Turing machine, Alan Turing is called the father of modern computing. Why? Because the computer was based on the thought process of Turing machine. But Turing machine was an advanced thought process of finite automata. Right? Finite automata, linear modeled automata, pushdown automata, and finally Turing machine. Right? So please go back. So in that the thought is, when you are in multiple states, you finally come back to, you can consider that as one state. So when we are looking at quantum, n qubits, when we talk about, so I can be at not n states, I can be at 2 power n. That is the power. Now when they talk about 156 qubits and 176 qubits, what does it mean? 2 power 176 states that processor can be. Okay? So what happens? That much of computation can be done, and it will finally collapse and give you the result, and the result will be accepted. So that is the power that you are going to get. Now second question, you have to think about the hardware in a processor. How is it happening? How is it happening in processor? Now you say processor has speed, gates are there, obviously, logical gates are there. That's why they say classical gates equivalent, NAND and NAND gate equivalent is available in processor. But the C0 gate and Hadamard gate, they are not available. So there is a separate power which comes with quantum, which is not there in classical. That's the difference which you are trying to understand. Now, so let us go back to classical thinking and let us have logical gates there, and we have a processor. We say, what do you say? Either they say flops. You would have heard about flops.
Set of registers.
Flops is different. I am talking about flops. Petaflops, teraflops. Operations.
Operations. Operator, operator.
Ah.
Likewise we will do.
But the question is not answered. What are flops? How do you measure a processor? Okay, you say the processor speed is 2.5 gigahertz. Most of you have purchased a laptop, so you know 2.5 gigahertz. What is meant by 2.5 gigahertz? Where vibration is? What is vibrating?
Storage space.
Seriously,
Storage space.
it is related to only processor item, right? Processor speed. So don't go beyond processor. Inside, come into the processor. In the processor, gates are there, transistors are there. So very large scale integration. More and more gates are coming. more and more operations can be performed, hence the speed is increasing. But the speed is dependent on frequency. Right? Now, you cannot have, okay, when I purchased laptop, it was 2 gigahertz. When I was a student in 2004 MTech. Right? 20 years later, what must be the speed? 2.4 gigahertz or some 10x, 10 must be there. When I started teaching in 96, so there was a 2097, 200 megahertz server.
100 Mbps.
Sir, our time. Right? So there was 200 megahertz server, and they would not allow me. A fresher, you are teaching a state, you stand outside.
Yes.
Outside the gate, you used to stand and see that 200 megahertz, full chill air conditioning. And they would not touch us. After that, we became friends. So then I used to sit there only. I used to have lunch on the server. Then that fellow used to say, hey, because of closeness also, so much closeness should not be there. If somebody sees you eating food here, I will lose my job. Food, I will also eat food. So we used to sit there. Later, we realized nothing will happen to the computer, even if you have lunch. Right? Earlier, they would not let off your chappal and come inside. Right? Slowly things changed. Right? And that professor recently, 5 years ago, he was telling me, you don't need air conditioning for computer system. Agreed. Right? Now we are like this laptop will work. No, air conditioning is not required. Right? So the point that I am talking, let us go into the computer. In the processor, now the frequency is there. How are operations happening? And how can I say this is the speed at which this computer is working or processor is working? And the power of this processor is based on that floating point operations. I give you the answer. Let's save time. Flops. Flops means floating point operations. Right? So if it runs at some teraflops, it means so many floating point operations per second. Now what is floating point operation? There are some integer operations. And exactly, your point is there, sir. The measurement. What is vibrating? Sir is stuck there now. What is vibrating?
It will show the frequency of that measure. Vibrating.
Each hit, there will be some.
That is what I am asking, sir. What is vibrating? Actually, see, I am not a guru. But what has happened is I started asking these questions. When I started asking these questions, nobody told me in any quantum this thing. So what I did is I digged and found the equivalent answers. So that's what I want to show, so that you will be confident in the class tomorrow. Quantum is not in the Hava. Every time the Gallo jagutunnadi anta. The reality process vachesina tarvata we cannot say it's all in the air. Earlier quantum process was not there. Why I told all these is because of why I am telling all these also is because someday some of our students must do something what QPI. Right? So I talked to that fellow. One fellow is BTech one, some 5 years experience in quantum. He was working as an intern in quantum, and because of that he started working and he developed this whole thing. And then they set up the company and they created. Government says we gave them 25 crores and they did the quantum this thing for us. But actually these fellows told we had to prove them that the quantum is working. Then they gave us 25 crores. So what actually happened? Without the 25 crores, they built it. Right? Some money, maybe with some 20 crores, they built it. And after that, 25 crores came, and then they are going to enhance it. They are going to do their more business and do more qubits they are doing. So the question that comes back to us is, can we not start in that lines to go get close to the technology? Okay, we are at the simulation level, we are at the implementation level. We are not at the hardware. Why we are not at the hardware level is not only the question on quantum processor. You name an Indian processor. Any Indian processor? CPU or GPU? Right? There is no Shakti processor. IIT Madras has done. They built a
Bharat browser.
Like Bharat browser, like BOS, Bharat operating system. Browser is some other name. You can search Indian browser, you will search, you will get. Right? There is no Indian browser. Even if the Indian browser is there, we will use Mozilla or Google Chrome. Right? So that is the problem. BOS is there, but anyway, that's a different issue. We have to reach to that excellence level. That's the question. Now, why are we not doing is because they are training us. They means IBM included. They are training us to use not to develop.
Develop.
Not to design.
So now, government's challenge is you develop, right? Then we don't have to buy. India is very good. Modi is God. Others are telling. Other countries are telling. Why you know?
Because he built so many temples.
Government has passed.
Government has.
Government passed.
India is number one in something.
Making India.
Making India number one.
Number one in something.
GDP.
Not GDP.
Competing with others.
No, we don't compete. We are serving.
Made in India. He wants to start.
Last year only they reached next stage. They are number one. Why is Modi God? Because they are manufacturing so many things. Where they will sell? So Modi is God, Modi will buy. India will buy. They are making India feel that you are so great. Now why are you so great? Because you will buy all the things we are making.
Good market.
It's marketing strategy. Marketing. We have to break that marketing strategy. If you want to break, we have to manufacture. If you have to manufacture, we have to get close to technology. My whole session will be uninteresting from now because it's going to be technology. But the challenge hardware, right? I'm coming. I did touch it. But now I will talk about the technologies for doing that. Arey sir, this is not quantum. Because this is close to technology. What we are doing is we are running away from technology. You talk about cryptography, you talk about hardware, you talk, I teach blockchain also, and one of the researchers, she submitted her PhD recently. So, Indian blockchain? No. Lakshmi coin. You heard of Lakshmi coin? No, not Lakshmi Mittal was not involved. Lakshmi coin is the digital currency which India wants, but Indian government did not involve. But few people came together and started that, but it didn't work. It did not come in Bharat. At least Ethereum also did not. Bitcoin is very much okay. So the question that is there is why, when I ask students, why don't you do something on blockchain with me, BTech project you do? Answer cryptography. What is cryptography? Nothing. Okay, for some time it will be difficult. Same thing with quantum. Right? Something it will be difficult initially, but slowly as we start working with it, then. Now the question is quantum hardware. You have to understand and you can come from any background and pick up. Lot of software engineering friends of mine, they were never computer science guys.
Sir, just one small query.
Yeah, please.
IBM mainframes course is there, no sir? That course they will give for 6-7 months.
Yes.
We will get jobs in that course.
Yeah.
When I am in MTech.
Right.
Now, is there any facility for this? IBM will provide some.
No, see, once you are good at quantum discrete programming and processing, right? IBM will recruit or IBM's partners will recruit. There is no problem. So many jobs are there in that if you do a good work. In fact, 2 or 3 faculty who already taught here, they told sir we can pick few of them who are good in coding. They are writing some programs. They are doing something. So we can collaborate with them. Sitting here, Lodi and Ashwath and others, they told. Let me discuss because we are also building a small team. Right? Not I am working on teams, multiple teams. So across the country. So everybody is asking sir how to buy the hardware. How to. So these questions are there and we have to build the teams. In your colleges also, we have to come together.
Collaborate.
See, in MNIT also I am struggling to bring 3 people together on the table and discuss and finalize one thing. We wanted to start minor course in quantum computing at a slightly higher level than AICTE because it is MNIT. We have to do slightly higher. So to formulate that. Now the question is, everybody will say, who will lead it? Lead. Teaching, everybody wants to teach. Leading. So that is where we are stuck. Let him lead it. We will do it. That is not there. So National Quantum Mission projects, they are asking a hub and spoke model. What is hub and spoke model? One main institute will be the hub. Then there will be spokes. Right? So 3-4 colleges, institutions should come together and join and apply for a project. They don't want to give to single institution. National Quantum Mission, very clear they are that 3-4 people have to collaborate, come together, share the knowledge and build a project. Right? So whether we apply for National Quantum Mission or not is secondary. can we come together and start working together? Difficult. Electronics, physics and computer science, maths coming together is difficult. Computer science itself coming together is difficult. But the problem is, we can't carry on like this. Right? Somewhere we have to break that module and then we have to take a break and collaborate. Right? So please all of you start collaborating. I think ma'am is giving a break for you. So we will actually start the technical lecture after this. Ma'am told me that there will be 2 halves. So first half I thought, then I will start with 3 questions at the beginning and then we will go to the remaining.
Okay.
So we are sorry for all the